Okay, so now we're moving on to clustering. Now, clustering is the first unsupervised learning algorithm that we're going to see in this series, and it's very powerful. Now, clustering only works for a very specific set of problems, and you use clustering when you have a bunch of input information or features, but you don't have any labels or output information. Essentially, what clustering does is finds clusters of like data points and tells you the location of those clusters. So you give a bunch of training data, you can pick how many clusters you want to find. So maybe we're going to be classifying digits, right? Handwritten digits using k-means clustering. In that instance, we would have 10 different clusters for the digits 0 through 9, and you pass all this information and the algorithm actually finds those clusters in the data set for you. We're going to walk through an example that'll make sense, but I just want to quickly explain the basic algorithm behind k-means. It's essentially the set of steps, because I'm going to walk you through them and with a visual example. So we're going to start by randomly picking k points to place k centroids. Now a centroid stands for where our current cluster is kind of defined, and we'll see it in a second. The next step is we're going to assign all of the data points to the centroids by distance. So actually, now that I'm talking about this, I think it just makes more sense to get right into the example, because if I keep talking about this, you guys are probably just going to be confused, although I might come back to this just to reference those points. Okay, so let's create a little graph like this in 2 dimensions for our basic example, and let's make some data points here. So I'm just going to make them all red, and you're going to notice that I'm going to make this kind of easier for ourselves by putting them in like their own unique little groups, right? So actually, we'll add one up here, then we can add some down here and down here. Now the algorithm starts for k-means clustering, and you guys will understand how this works as we continue, by randomly picking k centroids. Now I'm going to denote a centroid by a little filled in triangle like this, and essentially what these are is where these different clusters currently exist. So we start by randomly picking k, which is what we've defined. So let me, in this instance, we're going to say k equals 3 k centroids wherever. So maybe we put one, somewhere like here. You know what, I might not bother filling these in because they're going to take a while. Maybe we put one here, and maybe we end up putting one over here. Now, I've kind of put them close to where clusters are, but these are going to be completely random. Now, what happens next is each group or each data point is assigned to a cluster by distance. So essentially what we do is for every single data point that we have, we find what's known as the Euclidean distance, or it actually could be a different distance. You could use like Manhattan distance, if you guys know what that is, to all of the centroids. So let's say we're looking at this data point here. What we do is find the distance to all of these different centroids, and we assign this data point to the closest centroid. So the closest one by distance. Now in this instance, it's looking like it's going to be a bit of a tie between this centroid and this centroid, but I'm going to give it to the one on the left. So what we do is we're going to say this is now a part of this centroid. So if I'm calling this, like, let's just say this is centroid 1, this is centroid 2, and this is centroid 3, then this now is going to be a part of centroid 1 because it's closest to centroid 1. And we can go through and we do this for every single data point. So obviously we know all of these are going to be our 1s, right? And we know these are going to be our 2, so 2, 2, 2, and then these are obviously going to be our 3. Now I'm actually just going to add a few other data points because I want to make this a little bit more sophisticated almost, if that makes any sense. So I'll add those data points here. We'll even add one here, and now we'll give these labels. So these ones are close, so I'm going to say this one's 1. I'm going to say this one's 2. I know it's not closest to it, but just because I want to do that for now, we'll say 2 for that, and we'll say 3 here. Okay, so now that we've done that, we've labeled all of these points. What we do is we now move these centroids that we've defined into the middle of all of their data points. So what I do is I essentially find, it's called center of mass, the center of mass between all of the data points that are labeled the same. So in this case, these will be all the ones that are labeled the same. And I take this centroid, which I'm going to have to erase, get rid of it here, and I put it right in the middle. So let's go back to blue, and let's say the middle of these data points ends up being somewhere around here. So we put it in here, and this is what we call center of mass, and this again would be centroid 2. So let's just erase this, and there we go. Now we do it the same thing with the other centroids. So let's remove these ones, let's remove these ones. So for 3, I'm saying it's probably going to be somewhere in here. And then for 1, our center of mass is probably going to be located somewhere about here. Now what I do is I repeat the process that I just did, and I reassign all of the points now to the closest centroid. So all these points that are labeled 1, 2, all of that, we can kind of remove their labels, and this is just going to be great, me trying to erase the labels. I shouldn't have wrote them on top, but essentially what we do is we're just going to be like reassigning them. So I'm going to say, okay, so this is 2, and we just do the same thing as before, find the closest distance. So we'll say, these can stay in the same cluster. Maybe this one actually here gets changed to 1 now because it's closest to centroid 1. And we just reassign all these points. And maybe, this one now, if it was 2 before, let's say like this one's 1, and we just reassign them. Now we repeat this process of finding the closest, or assigning all of the points to their closest centroid, moving the centroid into the center of mass, and we keep doing this until eventually we reach a point where none of these points are changing which centroid they're a part of. So eventually we reach a point where I'm just going to erase this and draw like a new graph because it'll be a little bit cleaner. But what we have is, like a bunch of data points. So we have some over here, some over here. Maybe we'll just put some here, and maybe we'll do like a k=4 example for this one. And we have all these centroids, and I'll just draw these centroids with blue again, that are directly in the middle of all of their data points. They're like as in the middle as they can get. None of our data points have moved, and we call this now our cluster. So now we have these clusters, we have these centroids, right? We know where they are. And what we do is when we have a new data point that we want to make a prediction for or figure out what cluster it's a part of, what we do is we will plot that data point. So let's say it's this new data point here. We find the distance to all of the clusters that exist, and then we assign it to the closest one. So obviously it would be assigned to that one. And we can do this for any data point, right? So even if I put a data point all the way over here, well, its closest cluster is this, so it gets assigned to this cluster, and my output will be whatever this label of this cluster is. And that's essentially how this works. You're just clustering data points, figuring out which ones are similar, and this is a pretty basic algorithm. I mean, you draw your little triangle, you find the distance from every point to the triangle, or to all of the triangles actually, and then what you do is just simply assign those values to that centroid. You move that centroid to the center of mass, and you repeat this process constantly until eventually you get to a point where none of your data points are moving. That means you've found the best clusters that you can, essentially. Now, the only thing with this is you do need to know how many clusters you want for k-means clustering, because k is a variable that you need to define. Although there is some algorithms that can actually determine the best amount of clusters for a specific data set, but that's a little bit beyond what we're going to be focusing on right now. So that is pretty much clustering. There's not really much more to talk about it, especially because we can't really code anything for it now. So we're going to move on to hidden Markov models.